this function, hasn't called it, it's created this function, and there's a reference here in memory. This is the memory on the left hand side. There's a reference here so that it knows that next underscore number is pointing to where this code is for this function. So we're going to click on the next button and we're going to execute line 5, and that's going to declare a variable called a and assign the integer 10 to it. So you can see what's happened in the global frame here. This is just the memory in your computer here. So it's created the value 10 in memory, and it's labelled that with the variable name a. So consider this as just a box that we put the value 10 in, and we've given it a label that we've called a. So the next line of code here, we call our function. And notice how it's created a new frame specific for this function here. So what we see here, this is sometimes called the scope of variables. This variable here, n, is only visible within this function here. So we can't actually see the variable a in this function. So we've called this function and we passed it the value 10. So the variable n, again, it's just a box in memory. The variable n has the value 10 in it. But notice it's a different box than where the value 10 is for the variable a. So now we're looking at this blue global frame here, this frame here that's specific to this function. So let's see what happens as we execute this function. We're going to execute line 2. So that creates a variable k. And note how that's not visible to the code down here. So this frame here is visible to the main part of code down here. This frame here is visible to the function next underscore number. So we've declared a new variable k, so we've defined a new box for that, and we've assigned to that the value n plus 1, which is 11. And then we've got our return statement, and what Python Tutor is telling us here is telling us what that return value is going to be. And it's k, so it's created a new box for the return value with the value 11 in it. So now when we click next, it's going to go back to line 6. And what's going to happen is it's going to create the variable c and in this frame here, and it's going to assign the return value from the function to that variable. So notice how the frame for next underscore number has now gone. It's no longer there. Those values, we can no longer access them because we've returned from our function. So k no longer exists. And so c is now the value that's been returned from the function, which is 11, and we print c. And the output in Python Tutor appears in this box here, and that is the value 11. So let's go back to Codio and write some more functions. Let's write a very simple function called pi that takes no parameters and just returns 3.14, a literal floating point number there. So let's test that out. Print pi. And even though it takes no parameters, we have to put the open and close round brackets in. So let's just run that. And there we go. It displays the value 3.14. So let's make things a little bit more interesting and define another function, which we're going to call print underscore double. And that takes an argument or parameter n. And what we're going to do is print, we're not going to return this time, we're just going to print out and double the value that we've passed to our function, so n times 2. So down here, when we write some code to invoke our function, we don't have to put a print statement in, do we? We can just call print underscore double, and let's pass it the value 5. Let's just run that. And as you can see, it displays the value 10 there. So let's look at the differences between these functions here. The functions take arguments, the one here does not. But let's look at the return here. These two functions return a value, which means that they're fruitful functions. This function here doesn't return anything, so it is a non-fruitful function. So notice when we wanted to print pi, we had to put the print statement, call the print statement explicitly in our code down here, because pi is returning a value that is then printed. Whereas when we call print underscore double, there's no point putting a print statement here because this doesn't actually return anything. And in fact, it'll return the data type none. And indeed, if we did try to assign what is returned from print underscore double to a variable, so let's see if we can do that. C is equal to print double 5. Now that will run without any problems, no errors. But if we then try to print out the value of C, what will we get? We get none. And that's the Python interpreter telling us that C is actually a null object. So C doesn't actually point to anything. There's no value in the box. And that's what the interpreter is telling us there. It's not been initialized to anything. And that's because print underscore double is a non-fruitful function. Okay, note also we could put a return statement in here. It is optional, and this wouldn't make any difference to this code. This would still be a non-fruitful function because it's not actually returning a value. So this function is exactly the same as this function. We can also nest functions. So we can call functions within other functions. And this is a very powerful programming technique. So let's example of that, of functions calling other functions. What I'm going to write is a function called next number even that takes an integer value and will return a Boolean. It's going to return a Boolean of true if the next number is even, and a Boolean value of false if the next number is not even or odd. So first thing we need to do, rather than duplicating the code in this function here, okay, it's only one line of code in this particular case, but in more complex examples, it could be hundreds of lines of code. We're going to call this function from within our next number even function. So we're going to assign the result of calling this function next number. We're going to pass that the value n, same value that we've been passed into this function here, and then we're going to determine what the result is. We covered Boolean expressions extensively in the last topic, so hopefully this will be fairly obvious to you. And to check to see if the number is even, we're going to take the modulus of 2. If the modulus 2 is equal to 0, then we know the next number is even. If k mod 2 is equal to 1, then it's going to be an odd number. And at this point, we can just return the result. So, I've got to delete these lines of code now, just to tidy things up. And let's just set a is equal to 10, and then we're going to print next number even a. So let's run that little bit of code.